right, we are back for the morning session, and our second stakeholder is Vukosi Marivate, the Absent Chair of Data Science and Associate Professor of Computer Science at the University of Pretoria. Welcome, Vukosi.
Thanks for having me.
And we had specifically invited Vukosi partly to educate, I think, ourselves, the technical team and the public on AI, because it seems a bit impenetrable for most of us, but I'm hoping after this we'll be a lot more enlightened. So thank you for coming.
All right, thanks. So do I go on or?
Yeah, you can certainly start your presentation and talk us through. We've got 2 hours, so we have plenty of time.
Okay. All right, thank you for this opportunity and also for the introduction. Yes, I'm at the University of Pretoria running the Data Science for Social Impact Research Group or Lab. I'm also a co-founder of 2 grassroots AI organizations that work to really make sure that African AI is something that we champion and make sure that Africans shape this ongoing revolution, both in AI in general and then in language, more specifically when it comes to Masakane. I also do spend some time at Delapa AI, which is an AI startup based in Johannesburg, and I sit on the board or a steering committee of the Lacuna Fund that funds the creation of datasets for AI, especially across the global majority, or global south, if there's a lack of a better word, inside there. That's our lab at the university, made up of many staff members, senior members, students, and about 70% of the work that we do is in the intersection of natural language processing and African languages, and the others is data science and society. And I hope by being here, I am also fulfilling our part in data science and society and making sure that we can form as a voice that people can trust. Given that we are a university lab, we do have some support from different organizations, as was said at the beginning, one being from APSA for my position at the university, and then a number of research grants and gifts that we get from a variety of partners that work with us, whether supporting students, supporting postdocs, or supporting infrastructure that we need to go ahead and do our work. But yet, I think to maybe say, given this, we do value our academic freedom within this and being able to do what we do more for the benefit of society in doing our research as opposed to sponsors or people. What are we going to do in this talk? And as I said, thanks again for the commission for having me, the technical team, and then also to the public, is we want to build some understanding of fundamentals. I know for many, if we think back, is the 30th of November 2022, when a large language model became public and people started using it. It was a flashpoint. But there are things we can all get to understand jointly that get us to really know some of the things that happen in the back end. And as such, then we need to demystify and then share some food for thought in terms of thinking further than just this talk. So to kick us off, let's first start with actually what's AI and machine learning, right? Before we get to the fancy things. So we're going to go from 0 all the way to actually some of the services that you might be using on your phone or laptop. So what's artificial intelligence? In a classical definition, you have an agent, it exists in some environment, it takes action to achieve some goal, right? The humble South African robot lives at a corner of a street, right? That's its environment. It can turn from green, orange to red. Those are the actions that it takes, and the goal is to control traffic. That's an artificial intelligence, right? That's just to show that we build on from there. You can have a robot vacuum cleaner there. One of my twin daughters is looking at in our house. The house is the environment. It can move around. It can vacuum. It can avoid obstacles. Those are the actions that it can take. And then the goals are to keep the house clean. right? That's another artificial intelligence. And you can now start kind of thinking about systems that are like this everywhere. What's machine learning? So machine learning is a subset of AI that deals with learning patterns from data. You will hear these normally interchangeably used, but in just setting up definitions, we learn patterns from data. Right now, we're going to talk about supervised learning, specifically classification or categorization. So let's say I give you a surface. It's a flat surface here. And then I give you 2 data points. So their positioning is important, but then also is their color. So I give you 2 data points, one being red, one being blue, and I ask you in the future, if I drop a data point somewhere on the surface, so let's say here, what color would you predict it to be, given that I've given you those pieces of data before? So what you need to do is you have to learn some kind of a discriminating function. And the easiest one, given the 2 data points that we have here, is just a simple straight line that splits the surface into 2. And it says, anytime in the future, if something falls on the left of that line, I'll predict that it's red, even if I don't know what the color is. And if it falls onto the right of that line, I will predict that it's blue. Right, so that we've just built, that's our first kind of discrimination function or classification function. Yes, life is not that easy. Typically, you don't have things that are just as easy separable. It tends to be that your data is more complex. Because your data is more complex, the pattern you have to learn also becomes more complex. So you see now you've got almost like a quadratic equation, a line that is now squiggly instead of just being straight, right? Instead of just being y is equals to mx plus c. In this new one, anything that's above the line in the future, I'll predict that it's blue. Anything that's below the dotted line, I'll predict that it's red, right? So you can see that you can go from data and then you can learn this discrimination function, and it's useful for doing predictions in the future, right? So this is classification. We can take a leap, a semester or 2 in AI and say, this is how we get to, you have systems where now you can take an image that you're seeing there and then push it through these, what we call deep neural networks, which is really a parameterization or that discrimination function. That's what that deep neural network has, is that function, and then it tells you at the end of the day that what you have in that image is a dog and not a cat. But that's what's happening. We go from that fundamental simple thing, you can now extend it to much more complicated models, and then that's what this model is trying to do in these spaces. So we might also have sometimes that we don't have that label. We don't have those colors. All we just have is dots everywhere. But we can look at those dots and then try to look at the shape and say, is there something we can read into those dots on the surface? And yes, this is what's called unsupervised learning, where you cluster, here we're trying to look for 3 clusters, and what we're doing is just changing those discrimination functions until the clusters seem like they're self-contained properly, right? So this is called unsupervised learning. Remember the first one was supervised because you're giving it the input, where the dot is, and the output, the color of the dot. Right, this one, you didn't give it any colors. You just have where the dots are, but you can learn some patterns in the data. Right, so these are 2 important points because we're going to use them as we build on when it comes to language. Why do we do machine learning? Without machine learning, you would have to come up with a recipe to find these things out. So in the example of a dog, you would say, if there's an image of a dog, that it would have some parts of it having pixels that add up to an ear. There might be a snout somewhere. There will be feet. And only if all of these things are within relative distance to each other, that is a dog. Right? That you would have to write down that program, that recipe to find that in your thing. But with machine learning, you just feed it the data. You give it lots and lots of examples of the things that you want it to learn, and it learns that pattern itself. And that's why we're going through this major changes in machine learning, because now we can feed more data, we have more computational power, and the models can become bigger and bigger and bigger and bigger, and we're using them for many, many different things. Right? That's a major part of this thing. So hopefully then with some of that foundation laid, we can then start thinking about where language fits in. So here we're going to go through natural language processing. We know these through some of the breakthroughs we've been using for decades, right? Whether for some, the first time was using a search engine, right, of typing something and getting an indication of where to find something on the internet, or a spam filter in your email system, right? What would have happened? It processed the text that was in the email and then said that this doesn't look like, this is just spam, and it should just go there, right? Something happened there, right? In these spaces, there's now virtual assistants, you have chatbots, more and more use, and then translation systems as an example that are on there. We tend to think about natural language processing in terms of tasks. So here as an example, you have an input like Dumalamba Holo, output being greetings or elders, and this is translation as a task. You might have, it was one of the worst days of the year, the output being negative. This then is called opinion mining or sentiment analysis. So you can see, just like when we started and we looked at supervised learning, we're always doing input-output. Input, something gets fed in, and there must be something that we want the machine to learn to put as an output. Who's the president of South Africa? Cyril Ramaphosa. Just for context for people who might watch this a few years from now, this is 2024. Before the elections in South Africa. This is question answering and comprehension. You have received the credit of whatever, output being suspicious, this might be spam detection, and here you get a paragraph and you have an output as being a sentence. This is something like summarization. So these are all these different tasks that before the advent of these large language models, these would have been, you would build specific machine learning models for each of them. But with large language models, you can kind of now do all of this almost in one model, and we're building towards that of how that happens, right? So to do that, just to get people comfortable that machines can process language, let's actually build something together that's very small. So how do we get machines to process language? What we need is these things called features, things that you can feed into the zeros and ones, right, inside. So one is that you can treat words as atomic features. Right. So let's say we have a new language, and this language, just for kind of ease, we're going to just use English words here, but you could use anything else. We have a new language, it only has 5 words in it. Car, house, tree, drove past. Those are the words that are there. So one way is to use this thing called a vector. It's just a representation that allows you mathematically to express something, right? So we're going to express that the car is a vector where you have 1 followed by 4 zeros. And hopefully you will get the pattern soon. House is 0, 1, followed by 3 zeros. Tree is 0, 0, 1, 0, 0. Just like that, drove and passed. So just with a vector that is size 5, you can represent all 5 words. And now it's numbers as opposed to dealing with the words inside there. So now you could think and say, okay, how do I represent the sentence? One of the ways that you can do it is you can just say, oh, I can sum or add all of these vectors together, right? Depending on what words show up. So for car drove past tree house, it just becomes 1, 1, 1, 1, 1, 1, 1. Because each of those words show up inside the sentence. If a word shows up twice, you can put a 2. Right? If a word shows up 3, you'll put a 3 in the place where it's up, because you're just adding them together. The one thing to notice is we lose order. This representation, it doesn't tell you the sequence of the words. It just tells you that the word is in the sentence, right? So you could have lots of different orders inside there. But it's actually it's still a useful representation. You will see in the next slide. You can try to deal with the order, and one of the things you can say is concatenate. So instead of adding, you just append. You add to the thing, and now it just becomes this 1, 0, 0, 0, just like that. You add it to each other, but you'll see there's this thing, we say there's no free lunch. With this representation, it gives you order, but it becomes bigger. So to now write the sentence, you have an increase in the length of your representation. Right? So that is one thing. What can we do with the first representation where we lose the order? It's something we call term frequency. Remember I said if something shows up twice, you write 2 in there. Right? So because it's a frequency, you can think about document retrieval. So you have, let's say you have many documents. We call it a corpus. You have a search term queue. It's made up of these words, the thing that you're searching for. And you want to return documents that are relevant to queue. What you do is you count how many times the symbols you're looking for show up in every document, and you return the documents that have the highest sum of those words or symbols. So do you see how the first representation allows us to do document retrieval? Because all you need to do is say, oh, I know in the vector in this position, it tells me about this word. This is the word that I put in the query on my document retrieval or search engine. I'm looking for the word cup. And now it just says, oh, on all the documents I'm looking at, which one has the highest count of cup? And I return that to you. So these are the basic building blocks to a search engine, right? And that, what the corpus would be what we call an index of the search engine, right? There are different things that you will find inside here. So what we call this is a bag of words. We don't care about the order. It's almost like we just take the document, we shake it around, we take words, and we just count how many words we see for each of the documents. A symbol, a feature does not need to be a single word. It can be pairs, it can be triplets of these words, because maybe you might be looking for a phrase instead of just one word, those types of things. So there's ways to do this. Another thing is that you, in all languages, you have words like the, of, a, that are not really information as per your query, right? Those are not things that you want to focus on because they show up in all of the documents a lot. So what you might want to do, sorry, I just want to make sure, those you might want to de-emphasize them. And you have this thing called term frequency, inverse document frequency, where you change it, the equation, just to then multiply by, if a word shows up a lot across all the documents, it should just go close to 0. Is it me or? Okay. So it might be. Back? Okay. Yeah, so I was saying you can de-emphasize words that occur a lot because they're not really their information. So one way is just to remove them or by multiplying them just by the inverse, like 1 over how many times that word shows up, and then it becomes worth less. So yeah, we've built a search engine, and now we want to get closer to this language modeling thing, right, of what's going on. So in language modeling, what we're trying to do is also understand language semantics. So instead of just the part of we have the document being represented and we can do something with the document, we want to learn something about the language. And what I'll show in a minute so is ultimately it becomes math, and I just want you don't need to be scared. In this case, it becomes this math that you want to estimate this quantity here. This is called the probability of seeing a word given that you've seen in a sequence of words before. This actually has a common name that we all know and we likely use a number, like many, many times every day. This is autocomplete. Right, what are the chances, given that you've seen 5 words before, of every other word that is supposed to come next, and then we just choose the one that has the highest chance, and then we put it there? That's autocomplete that you see when you're typing in all of these services. So this becomes a very interesting thing, because if you can estimate this quantity, you have to learn things about the language, right? Some grammar, some, like, you know, the likelihood of seeing some things. So it's a very interesting thing that you want to learn. And this can be used for generating text, which is the thing we're trying to get to on our journey here. So one of the things we can do, which has been the thing that I was scared about, but we will do it, is we can actually build one together here. We're going to build a language model live. So don't worry here, this is a Python thing, but it's okay. We will go through this. So here we start. We start with a couple of sentences. Sorry, I just wanted to make sure that this is big enough for people to see. This is a beautiful day. It is a beautiful day for ice cream. This is going to be our input data into the model we are about to build. So we'll get through that. Don't worry about that, but I'll talk you through. So what we're going to do now is go through these two sentences and try to take triplets of words. So 3 words in sequence and move a window across. You will see why. So we take those, and here's how they come out. We have none, none, this. Why is it none, none, this? At the beginning here, there was no word before the word this. So what we do is something we call padding. So we add to the beginning a token that doesn't mean anything. It just says we were beginning, but because we had nothing before, we're just going to say it's a none. And then another none, and then there was this. Then there's none, this is a beautiful day. So these are, we're now changing this into different data points. If you've got that, you can now look and count and say, how many times did I see the word none and none followed by the word this? 1 time, given our small data. I can then do this for all of our things. Now you make it into a pair plus the next word. So now you see this is a, we saw it once. Is a followed by beautiful, we saw it once. Is a followed by good, once. Oh, something interesting to note there. Is an a has 2 times that it shows up in our data. And with those 2 times, the next word is different. It's not the same word. So we can change this count into calculating chance or probability, right? So if we transform this into probability, this is what's going to come here. Is an A, given our small 2 sentences, has a 50% chance of being followed by beautiful, and is an A has another 50% chance by being followed by the word good. Right? This is something that's important for us because now we capture that and we know this from the data. One of the things that we can then do, I'll skip that, is we can then ask the machine and say, okay, we're going to start with none and none. Can you tell me what the next word is supposed to be? After you figure out that word, keep on doing this. Unroll and keep on predicting into the future. So we've built the model. The model just keeps track of those probabilities. Everywhere else it puts zeros because it hasn't seen anything. It just puts numbers where it's seen the changes. And once it's done that, so for example, it says, this is a beautiful day. It is a beautiful day for ice cream. If we run it again, it might say, this is a beautiful day. It is a beautiful day. It doesn't say again, it is a beautiful day for ice cream. Why? Because at the is a, it has to flip a coin. One time it will say good, and then the other time it might say, good, like beautiful. You see, so now you see we went from just the simple representation that we've used. Hopefully we're coming back. I'm almost done with this one. We're not going to do something like this again. I'm trying to, yeah. Oh, there's a corner there that's missing. Yeah. Other things come in. Okay. I can work with it if it's a it's a thing. Yeah, work with it. Okay. Yeah. So it's a beautiful day for ice cream. So if we keep on running this over and over, because there's that branching that happens, it will always, when it gets to is an A, have a choice to make. Right? Here's again, is a good day for ice cream. It doesn't go and say it is a beautiful day again. Right? So that's an important thing because we've learned that and now we can generate new text, almost like new text. Sure, this data is not a lot. What we can do here, we've got some data that comes from Government Communication and Information Services, and we're going to load a big part of their data. It's the Vukuzenzele publication, and we're going to focus on the English for now. And we can do this across, this is 2,300 articles, and we can then do exactly the same thing we just did with those 2 sentences. with that, and welcome to live demos. Hopefully there's no error again. Okay, great. And we can do the same thing. And now we can start again. We're going to start with none and none and ask it. Given now it's gone through all these government documents, ask it to generate a text, and says there, the Ombud will intervene in matters of the outcomes of the past. Right, if I run it again, it will then start black women-owned businesses in the churches, synagogues, mosques, and all these things. So now we've just taken a huge data set and we've learned this big, what we call transition probability matrix, and now we can now start generating anything. It's not just learning the math or the statistics. We haven't done any big modeling as yet, but you can still do generation. Right, this one you can't ask it questions, and that's where we're going to be going in the next part of like, how do we get to a point where we see these machine learning models that now you can ask a question and then they respond, right? But you can see the building blocks have already started in this space. I'm just trying to see. I've loaded on my side. I'll talk through it as they fix that. So we've dealt with now building what we call a statistical language model, and now what we want to do is actually there's opportunities for us to change this into that into that machine learning problem, right? That classification problem, where you're going to have an input and you're going to ask the machine to learn the output. So one of the ways is that we can start with that process of just say, you have a set of words that came before. I'm going to give you those words, and we know now we can represent them as numbers, and we can put those numbers into our machine. And now we say, just predict what the next number is supposed to be. And you build a big machine learning model to do this, and you run it across lots and lots of lots of data, and then it learns what that sequence is supposed to be. Thank you. So as I said, we looked at building something that's simple that allows us to do this autocomplete, but you can turn it into a machine learning problem where you take as input like a sentence, you remove a word, and you get the machine to learn what is the word that you've removed. Right, so this is where these models called transformers became very pivotal in 2017 when they came along, because they could do this very well. And inside them, they could then capture some of the things we think, like, as grammar, as all these things that come from, it's a statistical learning. It learns what are the statistics of seeing a sequence, and if you remove a word, can it then predict what that word is? And that's where the machine learning part becomes important, right? So with these transformers, it allows us to scale this and then be able to also use parallelized programming to be able to do this very well. So what happens with this is that you have to do something called pre-training. So before we get to something like a ChatGPT, a Gemini, a Claude, or whatever, you need to first pre-train it with as much data as possible to learn this. It's called this task of filling in these missing words on there. So the first model was BERT that came from Google. And with BERT, you would take a corpus, a set of lots of books and Wikipedia in English, train this model, and now you've got this model that knows something about language, right? It's not everything, but it knows something about language. Then you take that, and then you fine-tune it. You continue training it towards your final task. One of these final tasks could be spam classification, right? That's one of the things that could be there. Or one is that you can just tune it to start helping you finish your sentences in your email. And this is actually, if you think about when BERT was released, was 2017, just after that, some of these features started showing up in people's emails, right? So that's one thing. So now the supervised training or this fine-tuning is important, because then you can then change it to many, many other tasks. And the tasks that I think a lot of people are interested in is how we get to these things of question answering. Right? So now you've pre-trained it on a large corpus to learn something about language, and then you fine-tune it or do supervised learning or supervised fine-tuning on a task. And this task now could be something like question answering. So here's a data set, for example, from it's called the Stanford question answering data set, has 100,000 question answer pairs. You're trying to get the machine to now anticipate that it's going to be given as input a question, and it must generate an answer that is related to that question. And if you give it enough of these questions and answers or prompts with probable answers, it learns to connect the patterns. Again, remember, the patterns of how do you answer a question. There's things like trivia QA. This one has 95,000 question pairs. And here's another one, which is Alpaca, which is a recreation of a model where you see, you give it, here's an instruction, that's here, and then give 3 tips for staying healthy, and then this is the output that you would have wanted it to generate. All right. So the machine learns from being given lots of these examples. And you can create them, and over time, then the more of these you have, plus the pre-training, the model starts generating these answers for you. So we've gone from just doing spam classification to now doing prompts. And if you do prompts, remember I had that task list at the beginning, you can just make those tasks just prompts. And now you can have one language model being able to be asked all of these different tasks, like please translate from this to this, and then it starts actually learning how to do that as part of the data. The thing that happened, though, that really brought us to most of where we are now is that it was great to get the machine to start, or the models to start generating answers, but sometimes the answers wouldn't meet the preferences of humans. All right, so you might generate things that are shocking, that might not be palatable, that might be biased. So one thing that happened was this Instruct GPT work that also came out of OpenAI in mid-2022, where it said that, no, what you can do is now, remember, you pre-train on a large amount of data for the missing word filling. Then you fine-tune on prompt question answering. And then you do one more thing, which is this called instruction tuning, where a human submits a prompt, they get a response, and then they have to grade if the response is good or not. And then this then closes the loop of getting the preferences that humans might have. So you could have these companies having lots of people who are just sending prompts, seeing responses, and then they grade or rate how good those responses are, and then the machine now learns to adjust. If you think about the early days of your big ChatGPTs, there was this question of, oh, is it left or right leaning? And it seemed that at the beginning, it might have, from political affiliation, was leaning one way. And as later, as people started complaining, it started moving another way. All of that is because people are trying to adjust this instruction tuning. It's part of this thing called reinforcement learning with human feedback. Right? You reinforce things so that it doesn't, do things that are off the rails. So you want to put some rails that it goes in. And this is also very important. And you see it in some of these models that they're generating. They'll either say, I can't really answer that in the way that you want. Right? So you needed to have all of those pieces available kind of to you. There are many language models. It is not just the ones that you think from the big tech companies. There are many of them. And because people are building them for very different things. There are ones that are completely open source. You can see the data that was used. You can see how the model actually gets trained. You can see how it gets fine-tuned, all those things, to other ones that are closed, where you can't see all of these things, but they're big. So GPT-4, the numbers there mean how many parameters you have to train or tweak. Right, when you have a y is equals to mx plus c, which is this linear, you have 2 parameters that you're tweaking, that you have to learn, the m and the c. And then here with GPT-4, you are at 1.76 trillion parameters that must be tuned. And you can think about how much training and how much compute, how much data is used inside there. And there's Gemini Ultra, and there's more are coming. And there's other ones that might be small, extra small, medium, large, those types of things. And this has really been a boom that has happened since about 2017 in building these models and getting to the point. At the beginning, we might have looked at Wikipedia, as I said, with the initial transformer paper for BERT that came out of Google. It was just Wikipedia and some books. Now you're trying to figure out how much data you can get from the internet to train these models. So in this section, I'll go through things to consider. Okay. For consideration, one is obviously we have to think, what's the source of this information that's being used to train these models? Is it credited? To whom? And did those people consent? They know that this might be used in this way. In some ways, there's this question of, is there compensation for some of this content, especially if you're thinking in not the right to research or fair use spaces, is there that part? And is also that if we're just using the internet as a training ground to get data, isn't it there's also the worst of the internet that comes into these systems? That's another piece on there. The other one for people to note is that there's this part of thinking that these are all-knowing machines. They are not. They skip also a big part of what we call information seeking, meaning that you typically you get some sources, you read the sources, and then you form your own opinion or a conclusion. So sometimes people think that these machines are, they've done that. And that's not necessarily what they've done. They've looked at, through the data that they've been fed, what are the things that are more going to be statistically popular, more likely to be a good response, as opposed to being, what if you yourself, given a specific context, if you read the source, you might come up with a different conclusion. Right, so that's another thing when it comes to these things. Okay. Then there are this work that covered on saying can you make these things too big, given that they have blind spots of things they can't see, and these might then have challenges with safety of using these models. There was also how we try to make them look like they are human in the way that they chat back and they respond. And this might then have unintended consequences, and we must think about these limits. The question then comes of where is the data that comes into machine learning in general, and a lot of it doesn't represent places like us where we're on the African continent. So this is just a visualization that shows for a specific time, we're looking at data sets that are used in machine learning research in general, not just in language, and you see that there's very little that is coming out of the African continent. And this could be very dangerous in that now if you're trying to provide context in building these models, if you don't have data, you could have responses that are not okay. And the other thing is we can think about this thing of, it's AGI, they can chat about anything that I want, but there's all these other things that we don't see. Am I off? Yeah. I don't know if it's me again. I'll speak to that one so we can move on. There's all these things that are at the bottom of the iceberg, just for context, or you see just the tree at the top, and you don't see that there's a whole root network under there, to be more contextual to being on the African continent and not talking about icebergs. But you don't see that there's all these other things that go behind the scenes of there might be challenges of workers who have to feed this information, who checks and make sure that there's content moderation. How do you filter the data so that you can clean it? All these things are not things that necessarily the public is thinking about when they use the system, right? But this work has to be done, right? Somebody has to do it. To close off, in some ways, as I said, we need a lot of pre-training data, and we need to think about where we get it. So we started off with Wikipedia. If we think about Wikipedia from the South African context, I'll give two parts as linking about 2019. That's where we had this table. So this was just thinking about Wikipedia in terms of how many articles are written in a South African language at that part. And if for English, there's 6 million plus Wikipedia articles that are written in English. Right? If you think about Afrikaans, I think it's already gone over 100,000, but you're already a factor of magnitude down. Then you go to Sepedi and isiZulu, you're now in the tens of thousands, right? And my wife told me this, to remove and put a zero. isiNdebele, for example, doesn't have a local language Wikipedia yet. Right, so if you are using Wikipedia already for the South African languages, you're going to have challenges with representing our languages inside. And remember, for English to, the thing that you're getting good, service when you're asking things in English and getting responses, you have 6 million plus. For the other languages, Chivenda, you were at like 367 articles. Right? And our demographics, as per the 2022 census, have also changed. It's Zulu, almost 25% of the country. It's speaking Zulu, then it's Xhosa, and Sepedi 10%. But the services for these services, they're not as good as that for English in one part. So Wikipedia is not big enough also. Just to also highlight this. And this is where crawlers come in. Right? So crawlers is that you have these systems online that are normally used for search engines that used to go around, they go to websites, they follow URLs. So what they would do is that go to a URL, find other URLs on the page, but then also download that page and put it into an index or a database. And then keep on following the URLs. And so it's like spiders, they move around and they crawl across the internet. And they download this, the data that's on the content that is on the web page into their databases, because this then becomes important for when you then go to a search engine and you type in a query. And they find the result, and then they show you that, oh, here's the thing that's connected to your query, and this is the URL that it comes from. Right? So that's where the search engine started, But now, you can use crawlers for different things. One, archiving the internet, so saving the content that's on the internet now. Believe it or not, websites do die, content does disappear, and also things change. And you might want to then have an archive of what the internet is like at all times. And you have projects that are doing this, like the Wayback Machine or the Internet Archive, that are always crawling and trying to keep copies of the internet. Then you can also use the same data to help AI learn. If you can then extract as much of this content that comes from the internet, you can now give these and train these models as well, because you now have so much content that is also in some ways diverse because it comes from a lot of content of the internet. You can then use this and you can filter. And this is where services like Common Crawl come in. So Common Crawl is an open project that aims to crawl the internet and make that data available for researchers to use, right? Right, and there's another one called Open Web Text. There's book data sets that just have books. Some of them are using only books that are already out of copyright. Some of them you might find have books that are still subject to copyright. You have social media crawls. There's people who are backing up things like getting Twitter data, Reddit, all these services. I think Facebook a long time ago tried to has been working to close off access to their services, so you couldn't actually use APIs. And then X or Twitter in the last year or so have also reduced or almost removed completely their research programs where you could actually get data from them. But that was a big thing. And also post the big large language model year that was 2023, a lot of these services have closed down free access to their content, their user-generated content, because they see it as an asset that now can be resold, right? So you have access to now this content that you can sell to all these AI companies that want to teach their machines things, right? So now, for us as researchers, we no longer have access to do research, but if you have enough money, you can get some kind of access, minus if there's now local policies that say there is a right to research and the platforms must give access, which South Africa at the moment doesn't have that kind of guarantee. And you might have scientific paper data sets like Archive and PubMed. So Common Crawl, just to provide context, as I said, it's huge. It's about 250 billion pages over 17 years that have been backed up. And it's always, the Common Crawl, it's always going and crawling the data set. So even if you might, for example, today block access to your website, but weren't blocking access to your website 5 years ago, they probably have your data from 5 years ago and going before. Right, so that's what Common Crawl has. As they say, they're adding 3 to 5 billion new pages every month. Right, and for context, I talked about Wikipedia, Common Crawl is 9.5 petabytes. Right, it's very big. And the models we're talking about when we build the LLMs are actually smaller than this. So what then tends to happen, just to highlight something else that happens is this bias thing, is that you are compressing what you are getting on the internet into these smaller models. And with that, that's why sometimes they also still have these blind spots. Because if you think about an image, when you take an image and you make it smaller, it becomes blurrier. because you're doing compression, so you lose information. The same thing is happening when you take these models. They're big, they take a lot of energy to train, but they're still not, it's not a one-to-one copy of what's happening on the internet. So that's another thing that brings up bias. That if you don't have enough of a representation of your language, of your context inside there, it just becomes even more stereotypical, right, because of this compression. That's a high likelihood of that. So the models are trained up to a date. So you see some of these models, when you ask a question, they'll say, I'm only trained up to X date. What happens to incorporate recent data? And there's many ways to try and resolve this, but one is called this retrieval augmented generation. So you now, given everything that we've learned today, you combine a search engine and a large language model. So when you make a query, one query goes to a search engine to say, please bring relevant web pages connected to this query, take those web pages, add them to the prompt that I made, and then send that all to the large language model, and the large language model responds faster. So this then requires that your crawler for the search engine still has to keep on working. Even if you're not retraining the large language, because it takes a lot of time and energy, but you are able to still respond contextually faster with new web pages because you are keeping your database expanding for your search engine. Right? So this is called retrieval augmented generation, and it connects us back to some of the place where we started thinking about web crawlers, right? And thinking about search engines at the beginning. Then in terms of now the impact of paywalls and crawling of information, at the the advent of search engines, there was this thing about having these crawlers and of saying most websites have a robots.txt file, and this instructs these crawlers if they are allowed or not allowed to crawl that website, or can only crawl certain parts of it and not everything. And it's commonly used to do this, and in some spaces it's almost like an agreement between all these organizations in a more distributed way that we do this. But you can have a paywall on top of that just is in this case, it's a protection measure that then says puts an electronic barrier that you can't see my content because you would have to have authentication to see it, right? And it can stop both a user and a crawler from seeing it because it can just be saying it doesn't discriminate. As long as you get to the URL, as soon as you want to get access to the content, it says, no, you must first log in one way or another. And this can also stop crawlers that disregard the robot.txt. Right, because the paywall can then say no, even if we don't have you on our do not crawl list, we have the paywall stops the people in there. But content owners or publishers can get into special arrangements with specific organizations that have these crawlers to say, if we know that it's your crawler because we can check where it's coming from in terms of IP, we can give it full access to the data without having to authenticate. Right, and there's the people who write the crawlers might ask for a tag and say, you must tell us where your paywall data starts, or your content starts, and where it ends, so that if somebody is trying to, we can use the full information to help us index, to make it better in some ways to search that content. But if we need to then give people an information about how we got your page, we only show the content that is not paywalled as part of responding to that person, right? So again, it requires that everybody keeps to the end of their bargain if that's the agreement that you're going to say. So paywalls is not necessarily that in some cases, they might not apply to some organizations that are crawling or some search engines. They could have agreements with some of the publishers to say, we get special access so that we can give you a proper way of indexing your information. We then promise, if that's the agreement, that we won't show the paywalled information to third parties when we respond to their queries. Right? That's one other thing. What does diverse data give to LLMs? It's better at processing things like more languages, because you can have diverse input languages if you can increase that diversity. It improves the context of questions. It's more knowledgeable as it gets a wider range of subject matter. And it includes more background because now you know more about other spaces, not just that it comes from like, Wikipedia and there's cultures. And it somewhat deals with some of the challenges of bias. So you can't remove it completely because the internet, even with like, if you've got all of it, doesn't represent everybody as well. Right, so there's some bias that you can reduce, but you don't remove bias completely because you have diverse data sets inside them. Local data, there is a role to play for local news, content, local language data because it can enhance some of the capabilities of these models. Remember, here we're making almost an assumption that everybody interacts with the world in English, and that's not true, even in South Africa. And the data that has been crawled, as I tried to allude to earlier, if one didn't have a blocker for crawling the data like a year ago, then some crawlers already have this going back 17 years or even more. And even if you put a blocker now, unless now you go to that organization and ask them to remove your content, it's still there. And with some of these data sets, because they are open and reshareable, you can't really remove your content because it's it's copied and it's everywhere. Right, in those spaces. But it's important to think about this, that having access to the content also gives us kind of this still, one of the things that Common Crawl does enable is a right to research and fair use research, because if you didn't have that, you wouldn't be able in any real way to say, I'm doing an internet study and I have a place where I can just go and search for a word and find all of the content and do that analysis. Right, so there is some parts for research that is publicly beneficial that these callers have a role to play. We work in doing work for African languages, and finding content that is written in our languages is important for us, and you need to have opportunity to do that. At the same time, private data from platforms is becoming, or it was already a big asset. So if you have content, even if it's user-generated, but that's sitting on your platform, a lot of these platforms are starting to protect it and say, like, no, they're not really easily accessible to outsiders because it also becomes a competitive advantage. Right? Either you can sell it, or you block your competitor from being able to train a large language model than yours because you've got users that are using your platform and creating content on there. And for us, again, thinking about a researcher who works on African languages, this has meant sometimes the closing of social media sites for us being able to do research on them means that we're losing access to people writing or speaking in their mother tongue, and us being able to then use that to build new language tools. Right, because of the advent that now you've got these the new, I guess, internet economy created by these large language models. And there is a lack of funding for local language development, and this also then impacts the general availability of tools. Right. I tend to ask how many people, if in the first language that you speak at home, have a dictionary on your phone or on your laptop in that language. There's typically very few people. Right, that shows you that we need the development of these tools to even enable other things that come on later on. Right, so there are challenges in processing these. At the beginning, in February 2023, some of the colleagues at Lelapa worked on, hey, can we check how well something like ChatGPT works on South African languages? So here's one asking ChatGPT during that time. They've improved it, obviously, but just showing you that if you don't have diversity and you're not improving your data and your modeling, count from 1 to 10 in isiZulu. And the response from ChatGPT was go 1, go 2, go 3, go 4. Right, another one was translate from isiZulu to English, kuyabiza kugibela ibanoi. And it says he insults by calling him a coward, and it was actually supposed to be it's expensive to get to fly on an airplane. Right, so, and then now, sure, these might have been fixed for isiZulu, but just think about the other languages where you're moving towards the margins. All right, that these can still be a problem. Even later when we were looking for there's things that are odd that doesn't make any sense. Like here, 1 to 10 isiZulu, this is another model, this is an open model, and it says Indlu, here's Maloni as 1, and that's not true. All right, so these are things that are still likely when people find them. Yes, you might laugh, but then if somebody is using it for information seeking, this is a problem. Right. So as I finish off, this is not just about web data. the infrastructure to train these models now is becoming really the domain of very few around the world. There's even increasingly for nation states that they can't train these models. It takes a lot of computational power to do it, large amounts of data and on them. And these language tools are required. You need them because to build up, you don't build on nothing, you build on top of other things. So these are important. And there is a need, not just in South Africa, but across the African continent to improve R&D, the local R&D ecosystems, right? In building the people who can do research, developers who can build on top of that research and get it to people's hands, engineers, all those things, organizations that are doing local R&D in these spaces, and investments to do it. It is not something that is necessarily, if we think about it, that it's going to be done by other people outside the continent because they would want to do it. It has to be something that's built here because of the context, of the ways that it makes that it represents us and the communities that we live in. So yeah, I think with that, hopefully I have been able to take you from, fundamentals to how the large language models at the moment work. There obviously will be other small details that are missing. I'm just trying to get people to understand their intuition so that I can inform the panel here and then also the public, and then we can then go through questions.
Thank you very much, because it was very, very interesting. I don't know if I caught everything, but certainly caught a lot. I want to take you back, though, to the issue of data sets and bias. I mean, your presentation showed that most of the input data sets are from the global north. And I'm wondering, what is the impact then on bias? But also, is this because the data sets are largely based in the global north, and that there's a lack of data sets for Africa?
Yeah, thanks for the question. So data is multi-level in terms of getting content, and you have to deal with publishers and how publishers might share for research. So some might say, no, we release some of our content for research purposes only and maybe non-commercial. So how many publishers are doing that? I think there's been maybe some conversations over the last 3 days about some of the dire state of the publishing industry. So that might still be a challenge because people are trying to protect the content that they think or they know, they can still make some revenue off. The other is just, how easily accessible is it? How many researchers are working on those languages? Because it requires a substantial investment. For me, it's not a cost. It has to be done. South Africa might have language policies, but it is not connected also to investments that work on building up those infrastructures. So that's just thinking about language. The same thing will happen when you're thinking about images that are representative of people here. It's a license, how easy is it to be licensable? It might be easier for people in the global north to make and say, we will release under open licenses. And it might be harder for somebody here to say that because of just how tight the connection is to revenue. Yeah, and then because if those things are not represented, then there's a higher likelihood of bias being within the models that are trained off that data.
But if you look at Common Caller, is it possible to determine on Common Caller how much of the content there belongs to media publishers, or is it anonymized?
If I remember correctly, I stand to be correct, I think you should be able to figure out what the URLs where they crawled. I don't think, because it has to be, I don't think they try to hide where the crawl has been, right? So you would be able to, even though it's 9.5 petabytes, you should be able to write a script to identify all the publishers that are captured inside there, and likely when last they were crawled, those types of information, yeah.
No, yeah, I think my mind's a bit blown at the moment, but I'll try work through. I just want to go back to the crawl and just so I understand. And so, I mean, as I understand, let's just take the search engine as a starting point. I mean, the search engine crawls the web to index and rank and it will look through the information on each website. So what is going in the index and the ranking? Is this just a summary? Is it the URL, or what is in that index?
It's likely the content that's in there. There can be, just as I said, like we represented a document at the beginning as a vector, there can be an embedding version of it as well. So this one where it's just the numbers, so that you can do easy retrieval, just to say what's similar to the query. But you will also still have the content itself saved inside the index as another part of that database. And then it will obviously be the URLs. There's metadata that might be specific to each search engine in terms of what's important for them. And you could do tagging that's also connected to, oh, here's how when you get information that's connected to this specific tag, you then represent it to the user because it has specific information. So you could have something and say like, oh, this person is a celebrity that is being searched for. And with that, there's other information that actually could be linked to the response.
So is it in some way a copy of the internet then, if you've got the content?
Yes, I think you have to, to build an index, you need to have the content, you know, because then when, especially having to respond very quickly and present it to the user, for a lot of search engines, they show a snippet. That snippet has to be in the database. It's not that now, at the time of the search, you then do a request to the original publisher and then ask to get back the snippet. That is one way to identify that the index has that content.
And that snippet is, I would understand from searching myself, I mean, is often relevant to my query. So although it's a big page, I'll get the excerpt that is relevant to my query, and that is what may make me click through or not.
Exactly, yeah. And with that is that there might just, again, be some more processing to just highlight, okay, I'm using more as a human to highlight which part of the full text actually is most connected to your query. And that's why it comes up.
Right.
Yeah.
And then you did say that at least you can differentiate the crawler. If you had a paywall, you can say, well, I'll allow this crawler in. And as I understand, that often is for search because you want your page to be well represented in results and whether it ranks appropriately or not. So often, even where people have paywalls, they'll let the search engine crawler in.
Yes. So that's why I was saying that in terms of paywalls, are an electronic measure to block access, and we could even go via geo blocking. This happens in some cases. For example, you could be at a university. I studied in the US. You could be at a university, go to a specific news publisher's website, but because they can identify that you're coming from a university that they have an agreement with, then there you don't see the paywall at all, just because you're on their campus and you are logged into the student. There's no exchange of information except that your IP address says you are at the university campus, right? So that is a similar way that if you have an agreement with an organization that has a search engine crawler, they can come into an agreement and say, no, for you, when we know that it's your IP where this crawler is coming from, we will just give you full access to our content.
But of course, if you have no paywall, then any crawlers coming in, or could you keep out some crawlers and not other crawlers if you're going to display to the public? So, like the media that we're dealing with, they're going to display to the public. They're reliant on advertising. So can you stop a crawler?
So you could do the robots.txt as a file, and then as long as the crawler respects the robots.txt, they can check inside the robots.txt file. And if that robot.txt file says if you are this crawler, don't crawl, and you respect it, you don't. The other one is that, again, you can have electronic measures. If you know what the main crawlers are, and there's likely database of people who keep track of where all these crawlers come from, you can just say, as soon as we know that this crawler comes from this address, then the website becomes inoperable or something. right? So there are electronic measures that you can likely make, but then you have to then make an investment in keeping, like, in some ways you probably might start playing a cat and mouse game, right? Because if some crawlers really want to get to your content, then they will find ways to spoof themselves or use proxies to get to you.
So robots.txt is an honor system. I mean, if that doesn't respect you, you can just go ahead.
It is akin to it, yes. Yeah, the robots.txt is akin to an honor system. It'd be very interesting if there's a case law. that in South Africa, maybe. I haven't seen it as yet. I had to talk to my colleague, Dr. Chijioke Okori, about this and say, like, okay, what do I say? Like, what's the basic? Again, I'm not a lawyer, so in this case, but yeah, at the moment, it's an honor system, but it can be taken as it's an instruction, right, that is being given to these crawlers to say you can or cannot.
But I think, as you said, I mean, it's reliant not just on the honor, but for you to put the instructions in there.
Yes.
And just keep your mic on, it's fine, I think.
Sure.
I mean, in your experience, how much of the South African web is savvy to all of this? And, I mean, you're an AI person. The kind of typical web developers and website developers are that help people put up their websites. Are they savvy to the full range of crawlers coming from wherever?
That I would not be too sure of, I'm not necessarily in the web development space, but in just thinking of convenience, which is normally where we start from, if I was thinking is that there's one part of looking at the benefits of being indexed, right? That for me, if I want people to find my content, being in an index is good, especially of the big search engines. So you might want to make it as easy as possible for them to find you. And to the point, I do have a number of personal sites, and with some of the search engines, you directly also register with them so that they can to kickstart the crawling. Right, you actually tell them that this is where I am, and please come here and find our content.
All right.
Yeah, so you could so there's a lot of things where it's a kind of like search engine optimization that people do, and that might then also reduce the likelihood of then being worried about the robots.txt. But that also right now, as this gets more and more into the public consciousness about how content is used. And on the other side, for training some of these models, that there might be some people who are starting to ask and say, oh, what controls do I have?
And I understand from you, there are many crawlers, and you could identify them, and they might have their own specifics that it's them that's coming, because you may want to let them in or not let them in. Yeah. So I assume, like OpenAI, they'll have their crawler.
They likely will, yeah.
And there will be some way you can say, well, if it's OpenAI's crawler, do I let them in? Do I not let them in?
Yes.
Because I think we heard from Media24 yesterday that they're also blocking AI crawlers. So I suppose you've got search engine crawlers, you've got AI crawlers. You probably have your own crawler. I don't know.
Yes. we do. Yeah.
I suppose for me what's interesting is, though, I mean, as I understand, when you bring AI onto a search engine, that they have to use the search index. I think you put it up that you would put it into their model somehow in order to now respond to fresh information and fresh data. So if they're accessing the index and they're not crawling the web when we put in a query, then it's whatever's indexed by the search engine that... And this seems a bit of a blurring because you've got the AI for training models, but you've got the search, and you've got search with AI, where it seems if you've given permission to the search engine, you've given permission to the AI.
Yeah, in some ways, I don't know. if there's specific agreements or contracting that might be coming on within the industry as a whole, whether it's the search engines and the search engines that also have AI in them. So that I don't know, but from a technical perspective, yes, you would think that there is a benefit that if you've got a very large index, training on that index is positive because the models become better. And then on top of that, then having this augmentation of retrieving from the search engine, that's why it's called retrieval augmented generation, retrieving from the search engine and then connecting it with the large language model gives you also better context, right? As opposed to just if you went directly to the large language model, it might respond with something that doesn't actually, like, if you're using something from the 30th of January and now you ask it when is the South Africa election for 2024, it might then have a response that is, not satisfactory to the user.
Yeah.
Yeah.
So, because this is a question I was sort of had coming out of Media 24 is you tell me you're blocking AI crawlers. Is that the training model? But you're not blocking the search engine because you want to be indexed properly and have your content appear. But if the integrated AI on the search has access to what the search engine has crawled, then what are you achieving with the AI?
So it depends on the setup, but technically, you can have a language model that is trained completely differently, and still connected with your search index. Right? That is a big part of the current wave that we're having in AI has been the open source movement that has really went on and said, like, we can build open source language models. And now you can take one of these open source language models and then connect them to your search engine without having like that. And that open source model, you would know where, they would say as much information as they could. Sometimes they don't, of where they got their data. And it might not be connected to your index at all. And that's possible. So I think there I'm just trying to clarify that you don't necessarily need to. It's just maybe the question of technicality that's being asked is saying, if I own the index and I built my own language model as well, what stops me from doing both with the same, both with the same data? And that might be the agreement that it is between the publishers and the person of saying, or the platform might say, we announce ourselves as well. We can announce that this is our search engine spider and this is our LLM spider. I don't know if that's what they're doing, and maybe that gives people more control. But in terms of if you own both and if you don't tell people, sure, who's to who's to really know until you have to start doing most likely investigation of what is the content that some people are trying to retrieve from inside the language model, right? But you can, the reason the augmented retrieval has become so interesting is that you can build your own index for something, right? It doesn't need to be a general search engine. It can just be for competition law in South Africa. And then you have an LLM that is separately built, not by you. And then you use that when people put up queries, the LLM responds with your database of competition law, as opposed to just giving general information that would come out of the LLM.
Yeah, and I suppose, to what you're telling is I just try and understand it. I could have trained on historical data, even the common crawl.
Yeah.
And let's say people have put up paywalls now. Yeah. But if I integrate it with search, I've got the fresh content. Yeah. So if that training of the model is just to be good with language and prompts and certain things, I then can augment.
Yeah.
So even if I'm not crawling the web now for that language model, I'm still getting the benefit of being able to respond.
Yeah. With fresh information.
Fresh. There was a former tribunal member who said, in the future AI will write our judgments, but can we trust Google to judge itself? But who knows? Maybe our life will be easier in the future. So I just want to go to one particular AI model which I came across, which is not really involved in these proceedings, just to understand a bit better, and it's called Perplexity, which is, I don't know if you're familiar with it.
I think I was talking to one of my students this morning about it before I came here.
Oh, well, there we go. Okay. But this seems to be, it's not part of a search engine, but it does crawl the web for content. And I suppose what it pitches itself, it's designed to look at fresh content and current events. So its crawler, it seems, goes out to crawl and index the web quite selectively, rather than maybe the whole corpus. But because it's designed to respond on current events with accuracy, trust, and timeliness, I think what was interesting is it starts to talk about prioritizing where it goes to look for information, because it wants to be accurate, and also because it wants to be timely. So just from your perspective, I mean, so can a crawler now start to differentiate where it goes in order to get information? As you said, there's a lot of spam out there, there's a lot of junk, there's a lot of hate speech, there's a lot of harmful stuff. So can it be selective in that sense, and how does that work?
Yeah, so we can think this through together so I'm not necessarily going to focus on Perplexity as is how it might work, but we can think about this from ourselves. Again, we're now jointly in this room designing a new LLM company. And then
what is my stake?
And then we think of we might want to only get content that comes from trusted places, right? So one, you could think of, there's government official announcements that we might want to keep, and as such, we can white label instead of black, meaning we whitelist, only use these government URLs as a place to stay. Then we might say, here's some news, some good journalists that we follow. Here's what their social media accounts is. We index only their accounts. We index only the news websites that we really trust. And we can keep on slowly curating basically the limits. We have a list of, these are the only URLs you can use, and we keep on adding and evaluating them by human. That's one way, right? So this then takes the human-computer collaboration going. That's one way to do it. It's a bit slower, it requires more heads in a room, and for some people, they might take it as it's costly. The other way to do it might be through click-through. Right? So that's why you might have some services that ask you to say, was this helpful or not? And now we say we'll release version 0.1 of our LLM and now start looking at the usage rates. And as we get the usage information, we now start looking and say, it seems people really are always drawn to these providers of content. And as such, we're going to start prioritizing that our spider also keeps the index fresh from those from those sources. And the ones that people tend to always say either, no, this wasn't a good response, or wasn't good for me, or people never visit, those get deprioritized. That the next time the spider, it's almost like you give it you give it a budget to say, you have these many hours today to crawl, and these are the ones we would really like you to get to. And these other ones just become at the bottom of your list. So that's a second way we can think this through, right? That we can have a technical solution that does what the human curators would have done, but in a way that is necessarily can always be happening as you're getting user information, as you're getting results and seeing how people are using your system, that goes back. And I have a feeling that it's likely that even people like Perplexity are doing both. Right? You have the human curation plus the machine just having some algorithm or recipe to follow in figuring out how to prioritize and deprioritize content.
And I'll come to what they say they're doing, because I love AI chatbots because they tell you things about themselves too.
Yeah.
But if they've coded language like you showed us, I mean, this may be a dumb question and I may not have followed everything, but are you basing your trust and accuracy on the site or on the content? Because if the content is just noughts and ones, can that tell you anything about the quality, accuracy of what's on the site, or do you have to select the site first?
So there's always going to be a bit of both here, because in terms of, using the word notoriety, hopefully in the right way here, if to be noteworthy, right, is that you could be a random person with a personal blog and you write about a specific topic and you are the best person in the world, that when people visit that small blog, they know that this person is the expert in this area. Right, you can literally be somewhere in the Eastern Cape, in right near the sea, and that's all you do. So the point is, now if through the click-through information, it becomes very apparent that if somebody's searching for this, it tends to be that the small blog, not a major publisher, the small blog seems to be where people are really trying to get to. Then you then say, oh, this becomes priority. Right? That's the information that you get necessarily from the click-through information. But that click-through information has to be connected to the zeros and ones of, what was the search about? And how do we now connect it to the click-through? Right? It's not general, it's contextual to, in the search, when people are searching for this, there seems to be that the people who are looking at this topic are really interested in the writing of this one small blog.
So you're almost looking for signals. You
there's a signal that is connected to...
You either know it's there, or you're looking what people are doing, but you can't analyze the content itself.
Without... you need to have something that is giving you information, right? You can have something else, like now you might say, okay, I am looking for good writing about cars. What would have happened before is that likely you would have had to teach the model what is the definition of good writing. And now with that, you then can go into the index into your data, into your index without having to go out. But that's it's a narrow, it's a narrower question than just saying we want something that's fresh, that's giving us those things. But there are ways to do that, but you would have had to do the pre-work to have definitions of the questions that might be asked.
All right, because interestingly, when I did ask Perplexity where it got its information for accuracy and reliability and also timeliness, I'm sure, as you can guess, up come the media, academic articles, industry reports. But I suppose what also surprised me was also some social media discussions, but maybe, as you say, this is not my discussion. It's someone like you who has a little more knowledge that they could be prioritizing and indexing.
Yeah. And remember, even with that, you can kind of piggyback on other people's prioritization, right? So if you know a social media, again, we're doing the thing of we're building this thing together and we're going to spend as little money as possible to get this company going. And we could say, there's another company, and this company always advertises on their social media platform. They advertise who their top experts are. And we just keep track of that list. And every time they add a new person, we add that person onto our onto our crawling list as well. So you can do that. But the question then becomes, as I said, like once you do stuff, like if you do only the curation ourselves, it goes back to the question of bias. How do you evaluate for South Africa who are the trusted sources for academic content, for the news content, and then once you then scale it to, we have 54 African countries, how do you do that? How do you go across languages? Maybe the most useful content in those spaces is not in English, is not in French, is not in Portuguese. Is that indexed as well?
No, and just take this morning from Chris, his sites are invisible. So community media, no one's listening to them, because then it seems web crawling, and of course crawling the social media as well, but those are getting blocked off because they're owned by the social media companies. That becomes the primary input into a lot of AI and fresh knowledge.
And you do have another thing that is connected, I think, with that, just to highlight, is even with the media companies, we work, I didn't have a slide on this, for example, we're working on getting off the ground a collaboration with Tabela, which is a small Xitsonga language community newspaper based around Polokwane. And they will have their audience, and you can get their audience. I can think it has relevance of who they're trying to get to. And with some of these, we see, and the way we see them as researchers sometimes, is you see these online communities that are very active, right? Mm-hmm. In their language, speaking, engaging, and all those things. And with proper responsible research, you're like, oh, it'd be great to just observe the use of language and things. But now that's again gone. And it's still connected with the publisher, that the publisher created the space using a platform, but they also themselves likely won't get the benefit of curating that community that could also help them in understanding how other people are seeing those engagements.
And that's what's interesting. I think, over the last few days, it has been highlighted that Google is not so great for vernacular language, at least for newspapers and community papers in South Africa. But the social media sites are where it's all happening, because language is maybe easier because you're just typing in. It's not trying to index, assess, and rank and determine what comes up. So a lot of the vernacular content and data sets are going to be on social media.
I think on one is that there might be different, I think it's great having conversations between, but there also are different maybe goals that people might have versus a search engine, even what a search engine company might be doing in those spaces. Because in some ways you could think that the technical solutions are universal, maybe some parts of them are not, but how to switch languages is becoming better. There's just on general research, it's not ideal. There still has to be more work that has to be done in these areas. But yes, again, it's the comfortability that you have communities. The things that have been amazing is finding communities of people who just write short stories in a language and they're putting it on some social media site. All right, and then they're just saying, oh, we share short stories for us to keep our languages going, right? And then we write these things for each other. It's not necessarily they're writing it for the LLM or for us, but it's something interesting that kind of they're doing. And yes, how those things are findable becomes tough in some ways. And this is some of the reasons why having local context, right, is important, because then you have people who work on the research, on the development who are here, who are in those communities, and they know, like, oh, here's how you can find those kind of things. I can interact with community newspapers in the languages I'm interested in. Some of my other colleagues can interact with community newspapers in the languages that they are. It is not necessarily that a very large crawler will understand some of those nuances.
And just can help me understand the sort of language crawl aspect, because I mean, part of it, based on what I understood from your presentation, is just being able to do the natural language processing in that language, which is just having a lot of text in that language that you can feed through the machine, and it can build a better understanding. So would some of the content, just to bring it back to our inquiry, I mean, on vernacular language publishers, Isolezwe or community newspapers, just have that value of just being able to build a good AI machine with those language abilities?
So there's different things that happen. So like I think for people to understand is that yes, at the moment I think we're limiting ourselves to text just because it's the easier thing to do. But you can do audio, you can do video, you can move into other forms of content creation. But if now you're trying to build a database or a data set, there's different ways you can do it. So one, again, you can always do the human curation. People who know where all of the isiZulu major content places come from. Then the other one is then the people who create that content can also tag their content with language identifiers to say, when you come to this website, we're telling you that the language that is used on this website or on this page is X. There's international codes that you can put inside there. That metadata is useful in some ways. Then another one is that you can deploy language identification. So language identification is now you have other natural language processing models that try to identify that is the content in this language or that language. So this brings us to filtering. So I might just be and say, for me, at the moment in time, I only care about English. And as such, even if I'm crawling the whole internet, I'm always filtering that I check the content. If in the content, my language identifier says this is 80% English, that's good. Once I get to 60% English, I don't even care what the rest is. I'm just throwing it out. It is not going into my index. Right? And there's a lot of work in building the LLMs to either do language filtering bad words that might lead to abusive content, those types of things, of saying, let's find these words, let's check in the content that we have, remove all of that content because we don't want it to poison the model. Right? And there might be other ways of saying, yes, we're going to crawl the internet and now try to make sure we build enough indexes that are in different languages. As I said, there's a question that comes from either the economics of saying, what is it that we're trying to do as an organization? And again, I'm hypothetical here. I'm not saying anybody's doing in this specific way. And for us, 50% of our customers are really just interested in the English content. If now I'm will I invest in now creating a specific index and understanding the nuances for a language that is in terms of use on my website number 2001? Right, like a very practical question. And that answer a lot of times will likely be no. So as such, your experience might be really very different to when you are you're working with one that, in a language that is very highly resourced in those spaces. And as I said, it's not so. Now we've identified language ID has to be there. So now, do we have tools for language ID for our languages that are very high quality? That becomes another question. Do we have word lists for filtering for abusive content for all of our languages that are good? Right? And the reason I ask this is that likely as we're going into election period, or you would have seen over the last year with some of the social media sites, there's a lot of things that end up on the sites that you go in and say, why isn't this content moderated? Yeah. And it's because the content moderation is typically also follows the same type of thing of you do content moderation likely in the languages that you have as good off-the-shelf tools or tools you can build very quickly. For things that you think are on more the fringes, then you don't have. So you can switch languages. So if you want to spread spam or misinformation or whatever, you can then, for some platforms, just start using a language that is not supported in the automated content moderation tools of that service. Right? And this is a question that saying that should bring us to think about how things like election misinformation is likely going to spread around South Africa in the next 2-3 months. right? It's that the content moderation tools that have to do with our languages are not as much.
Yeah, that is sobering thought. I mean, one of those. So, I mean, what I found interesting as well is educating here. I mean, as you say, we all got to know about AI in a big way when ChatGPT launched, but it's all the things that AI has been doing up till now, which is quite specialized, because I know there's that Google's C4 data set has come into frame because there is some litigation now, and Courtney showed us yesterday that news sites make up half the top 10. But that is a subset of data of the bigger common crawl. And I can't remember what the other two C's stand for. But something like that. But I mean, I also, just doing my own research, there's again a C4 data set that's there for grammatical error correction. You've talked about the predicted, next word.
There's another one called MC4, which is multilingual, where it tries to go inside the C4, but then now filter by language, so that you know that here's Swahili, here's the Zulu part of C4.
All right.
Yeah.
Because I was going to go there, in fact, and translation is going to be a big application. And I suppose translation, you need to understand the language, both of them, so you need that language capability, but then you also need to know how to translate. So what are the sort of data sets you're using to do that? Do you need something that's already translated, or are there other ways?
Yeah, so for everybody to understand, to know, so one of the things that's been great in the last maybe 5 to 10 years has been building new tools for also having representation of languages that is cross-lingual. So not just multilingual, but cross-lingual, meaning you have tools actually that you can give 2 sentences. You can give 2 sentences, one in Chivenda, one in Xhosa, and these services can tell you the probability that that's the same sentence just in 2 different languages. Right? So if you can do that, right, you can then start building up different, what we call parallel data sets. So parallel aligned data sets is to build a model that can help you. Again, let's think about the input-output. So you can change a translation model. It's just a system where you give it input in one language, and you want it to learn the output to be in another language. Right? So we're still sticking to the machine learning supervised learning framework. So what you need then to train that type of machine is as much data that goes from that one language to another. So you need people to either give you these parallel data sets that have all these sentences that are translated, or segments, or paragraphs to do that. In the past, this would only be people literally have to create them, right? So there would be people who just say, we will take this data in Xhosa, translate it to English as well, and then we align it, right? Then we know exactly what sentences are aligned. Now, more and more, what we do is we can get a big data set that has multiple languages inside it. We find the tags of each of the languages, and we run through programs that do that sentence-to-sentence matching. And you then say, I only want to keep the sentences that are 80% seen as being likely the same one. So an example of something we did at the university is we knew that the cabinet statements from government are published and they are translated into all of the languages. But now we want to do the alignment. And when we do the alignment, we just take the Xhosa statement, we take the Indebele statement, and now we just go through each of the sentences and just check which ones were actually, when they did the translations, are almost direct. And now we have that data. The same thing with Vukuzenzele, which I showed. We take from GCIS, we download Vukuzenzele from PDF, we extract it, we get all the sentences, and then we also align all of the sentences. And then because we tell people that, yeah, this is not perfect, it's not a human didn't go through every sentence and check it, we're using a more machine-driven comparison, but now you have data that wasn't there before that is aligned across these languages. Right, so there, the thing that becomes, again, important is the original data. Can you get that? So if you have something like MC4, you can likely do the alignment as well. It's just that it'll be more searching for a needle in a haystack to do that, while the what's this thing? The one for if you're using cabinet statement because you know it's the same statement, you already know that. You're just aligning sentences in a smaller set. So it is important, like if you're thinking about this, is that knowing that, oh, here's Isolizwe, and here's all their content in isiZulu, but if we assume that the content that they wrote today is likely about the stories of today, I can go to another publisher who writes in English and check in South Africa and check their content and see, can I align the sentences because they are likely going to be talking, it's the same, I've limited to a day instead of searching their whole.
Right.
Yeah.
That's interesting because they're reporting on the same event.
Yeah.
So there may be a lot of similarity.
Yeah. Inside there. You will throw away a good percentage because obviously if you're having, it's not that people are trying to translate each other, but some of them might be that it's the same thing that is just being said in two different languages.
I see we're almost out of time. I had maybe my dumbest question for last, which was, is there a difference between web scraping and crawling, or is it really the same thing?
You have to scrape to crawl, right? So you crawl, you move across. That's why we say, because you move, as I said, you follow the URLs. So it's almost like you're following a web, right? But to build the index, you have to scrape the site, because then after you've crawled, you scrape the content and you put it inside your index.
All right. No, at least that's clear for me now. Paul, please.
So maybe it's an unfair question, but a lot of media are obviously concerned about the impact of AI on their sites. Do you see it in the same light?
Oh, put me in a bad position. I'm always trying to ask them for access to data. Like, we need to have an informed public, and we also need to make sure that our values are represented in different ways, and we are going through, and this is my trying to answer by not answering directly. We're going through a period where I think we are renegotiating who pays for the internet, basically. I think that seems to be the big part here, is that we're going through that process at the moment. And it is worthwhile bringing the public into confidence of understanding the economics of how internet services work, what all of the pieces are, so that when choices are made, people actually understand why choices are being made. I think a lot of that had been just hidden, as we just expect free services and they just work in some ways, and the first time you interact with a paywall, you're like, why are they doing this to us? We just had access to this, but that is a major thing. So when thinking about AI systems, I think it's more than just simply economic. It's also thinking about, are they fit for use? Are they safe? And do they really represent us in the way that we want to be represented? At the moment, there's a feeling that, like, once you explain to people how they work, they start asking questions of like, but what happens when you do X? And those are typically the answers that a lot of people can't answer, right? And that's where having a space where I think researchers, for kind of in the right to research and fair use, can be, given access in a good way to build up these things locally is good in the same way. At the same time, yes, we understand it's your copyright and IP rights, and you need, people need to be able to enforce them in the way that they can. But it shouldn't be, for me, at the complete disregard for the development of our local languages. And that's it's a very tight rope to walk. It's a very, very tight rope to walk. And as I said, I'm at the university, and I have to say I'm also at a private company that is also building language models, and I live that contradiction.
But I suppose what you're also telling us is there are the tools to differentiate who's coming in for what purpose, and
You can identify those. It's just that if people, like, because you can provide what we call a header, just telling the site, oh, I'm accessing you from here. But then there might be things that don't announce themselves.
yeah.
Right? Also, I'll talk about scraping just for things. So you can scrape a website, and some people might have technical tools that just say like, oh, if the sustained downloading of, scraping of our content for a specific amount of time, yes, one, it could be a denial of service attack, but another one is that it might be somebody scraping the site, so block that person because we don't know them. Right? There are technical things to do that. We might do it because we're like, oh, this is interesting. We're trying to do some work at the university, so we just want to have a local copy of that content. We're not going to every time do that, but then we know for some services they'll say, oh, we saw that you just went through 1,000 pages in 5 minutes. That cannot be a human. It's a machine that is doing something, and because you are not one of our known spiders, we will now block where you're coming from. Right? Some of them can do it like completely, like say forever. This place doesn't get access. But if you're doing that, you then should know on the other side that it might be legitimate. And now doing the blocking, so you see how it again brings. You need to have the technical prowess to figure out who you're blocking and who you're letting through.
And that may not exist with every media company.
Yes, and in terms of the level of what that is, it might be different per company, right? Because then it's yeah. So somebody might be doing it for nefarious reasons, but somebody might be doing it for legitimate, reasons of saying, oh yeah, this is just for me. I'm doing some work, and I just want to have a local copy of all of these things. And it's unfortunately will go through 1,000 thing. And then some. It doesn't mean also all crawlers are bad that you don't know. Some of them you have. Just for people, for everybody, there was a service that used to, I think for the UK politicians, just keep track of when they delete tweets. Right? So at the beginning, on face value, you don't be like, oh, okay, why would you care about that? But it's very interesting what gets deleted. Especially from a person who's, in the case there would be been on the social media platform as a politician, as a public person, it's not their private, it's their persona as a politician. And now what you wanted to do, there was these spiders that just go and keep track of what the politician has written, and they just keep on checking again and say, oh, this person deleted it now, but you can go to a website and see, this is what they deleted 2 days ago. Right, so I'm saying, they might not announce themselves in the way that you want, but it doesn't mean they're not doing a service that actually is for benefit.
And may even be looking for misinformation.
Or misinformation, or doing something on building language resources.
Yeah.
There's other things that are going on that are just not, necessarily what we think. So it's just that, as I say, it requires that nuance.
Well, I think we need to bring the session to a close. I'm sure we could go on all day, but Vukosi, I can't thank you enough for the time you've given us, and the public and the media. I think, as you say, I think we all need to learn, and you've certainly done a fantastic job in simplifying it, and also giving us some of the real complexities of navigating this world. And I think your question was interesting about, is this about who pays for the internet? Certainly a lot for us to think about, and we do have some of those players coming next week, so I think you've also given us an insight that we can also engage them at a higher level than we would otherwise. So thank you.
Thanks, everyone.